This video is about the fault tree analysis, which can be very helpful for risk management and failure analysis. The fault tree analysis, or FDA for short, is a top-down analysis method used to understand how failures propagate within a system by finding the root cause. It provides a structured approach to identify potential failure paths and assess risks. FDA can be used to analyze an issue on hand to fix potential problems, and it can be also used proactively in advance to improve system reliability. You usually begin at the top with the overarching question of how the system can fail or already has failed. The FDA is then usually represented by a diagram that shows the failure path. And there are two main components in this diagram: the events, which are system failure, intermediate causes, and root causes, and the logic gates, which connect the events. Those are the known and, or, nor, etc. gates from basic signal theory. Let's see how this looks like. So at the top you have the main event, which is the system failure. Then it is important to understand the system architecture and the data flows to gather some insights about what potential intermediate causes are. The intermediate causes are direct contributors to the top event, so to the system failure, like missing messages, invalid sensor data, etc. And then you decompose these into root causes by breaking down the intermediate events step by step until you reach the root causes. Those are basic hardware failures, software errors, environmental triggers, etc. There can be more than one root cause for one system failure, of course. Let's look at an example of the humanoid robotics area. The system failure here is that the humanoid robot fails to maintain balance during walking mode. This is, of course, a critical and system level issue in humanoid robotics. There can be various intermediate causes for that, like incorrect state estimation, foot-ground interaction issue, or an insufficient lift force. All of those causes are connected by an OR gate, meaning that one of these issues can lead to the system level behavior or the system level error mentioned above. Let's look at the left side. Here there are two different root causes for the incorrect state estimation. It can be due to a calibration error or a sensor input issue. Again, both of those root causes individually lead to the intermediate cause of an incorrect state estimation, which then leads to a failure in maintaining balance. As another example, looking on the right side, here there is a cause for the insufficient lift force, which can be a combination of low battery voltage and increased joint friction. Those two causes or root causes have to interact together to lead to the cause of an insufficient lift force. So therefore, those two are connected by an AND gate. Also, you see that one of them is a root cause, which is the low battery voltage, and the other is again an intermediate cause, which has different other root causes and needs to be investigated further. So that is an example of a fault tree analysis that can help analyze the issue of a humanoid robot failing to maintain balance during walking mode.